Hello students, I am going to teach standard 9 chemistry, the periodic table, but part 3, the modern periodic table. In modern periodic table, the elements 118 elements are arranged in groups and periods. So groups means there are vertically, but periods means horizontal. Groups there are 18th groups, but periods there are 7 periods. So these groups are mentioned by 1A to 7A in Roman, 1 to then 13 to 17, then 1B to 7B and 18, 8 and 0 group. So these are all total 18th groups. There are 7 periods. So first period is only 2 elements, hydrogen and helium. So these are arranged according to the groups and periods. Then types of elements. These type of elements means there are 4 types of elements. One is representative or normal, another is transition, third one is inert transition, fourth one is inert gases. See table 5.2, there are different types of elements are mentioned, and the modern periodic table page 83 you can see. So these representative elements generally mentioned by 1A or A. If A, there is a representative elements. These A group elements are also in S block and P block. Then transition, which are in B block elements. Then inert gases or inert transition elements, which are that is F block, lanthanide and actinide. Then your inert gases, which is estimated right in the periodic table, that is inert gases or noble elements. So there are SPDF 4 blocks. S block means 1A to 2A, but P block is 3A to 7A and 0 group. But D block is transition, that is 1B to 7B and 80. But F block is which is below, that is lanthanide and actinide. Then what is bridge elements? Bridge elements means there are different groups and different periods. Then same character or same properties, may be metals or non-metals or metalloids. So one example, lithium and magnesium, these are in different groups and different periods, but both are metals. These are the bridge elements. Beryllium and aluminium, different groups and different periods, these are the bridge elements. Another is typical elements. What is typical elements? If their groups are resemble with their groups. The third period elements, sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine, summarize the properties of the respective groups and are called typical elements. Then merits. What is the merits? So according to modern periodic table, position of an element in the table is related to its electronic configuration. There are groups and periods. So in groups there is the similar properties. Modern periodic table is easier to remember. The based on atomic number. These are the merits. Then what is demerits? So only one point, that is demerits. Hydrogen is not placed, that is in 1A or 7A. Dual character of hydrogen. So in modern periodic table, hydrogen is not placed, but it is written in the front. Then general trends in the modern periodic table, that is groups and periods. So there are 18th groups but 7 periods. So let one example, 1A group. 1 means their valence electron is 1, but A means that is normal elements. So according to syllabus, I say syllabus, transition elements are not to remember generally. So periods, there are 7 periods. First period only 2 elements. Then second period, that is 8 elements. Third period 8 elements. Fourth 18th. Fifth also 18th. Sixth 32. 7 is incomplete. So shortest period is first and the longest period is sixth. Then there is properties. Properties means, if you see Atomic size. Atomic size generally increases down a group because due to extra cells are added. So cesium is the most metallic character or atomic size generally more or most of cesium. Then when you move from left to right or in the period, their atomic size generally decreases because in the nucleus there is proton. So increase in the number of protons increase the nuclear charge which attracts the outermost electrons and squeeze the cells. That's why when you move from left to right, their atomic size decreases except the noble elements. So if you see lithium to fluorine, atomic size of lithium is greater than fluorine. So one best example, that is cesium is the most atomic size or greatest atomic size, but your fluorine is the least. If you see according to chemical bonding, cesium is the most metallic character, fluorine is the most non-metallic character. So electrovalent bond between cesium and fluorine is cesium fluoride. Then metallic character. Metallic character generally down a group increases, but left to right increases first, then metalloid, then decreases as non-metals. So metallic character, then in the periods, if you move, the metallic character generally increases first, then middle is decreases as metalloids, then decreases or your non-metal. But down a group, metallic character increases. Thank you.